Hi, good evening, everyone. I hope people can see me and hear me. So welcome to today's webinar, one of the webinar with the longest name so far, running a DynamoDB-compatible database on managed Kubernetes service. So as the name suggests, we're going to include two topics here. One is the Dynamo-compatible API, as we call it, Alternator. And the second is running it on top of Kubernetes. Before we get started, a few admin issues. So throughout the session, you can ask a question. There is a Q&A button somewhere on your Zoom UI. So you can click it and ask a question at any point, but I actually cannot see them during the session itself while I'm talking. But we will be able to see all of them at the end, and we will have a Q&A session at the end, and then we will try to answer as many questions as we can. But you can and you should ask questions throughout the session. Just write your question. Also, the chat is open, and we will actually going to use the chat a little bit in a game, interactive game that will be part of this webinar. So you're welcome to chat there. In particular, if you can each write your name there, it will help us later or help you later to find the match for the interactive game. And we'll expand on that later. Last thing before we get started, this session will be recorded. So if you have to go to the bathroom or something, I don't know, in the middle, don't worry, everything is recorded and you can get back to it. So let's get started. And before I jump into the actual product, 2 minutes about ScyllaDB. ScyllaDB is the company behind Scylla, the open source and enterprise NoSQL database, which is a drop-in replacement for Amazon DynamoDB and also for Apache Cassandra. Scylla excel in very high performance and very low latency, in particular tail latency. It comes in 3 variants: open source, enterprise, and last but not least, cloud. Cloud, you can think about it as simply as a manage Scylla on the cloud. So you can go to cloud.scyllaDB.com. Of course, enter your credit card and launch a cluster, and we are managing the cluster for you. And if you actually go even during this session to the cloud, you can see that you can launch what we call an Alternator cluster. Alternator is simply the name that we are using for our DynamoDB API. And we're going to talk a lot about it in this webinar. So to present myself, I'm VP of product at Scylla. And before that, I can't even remember, it's too long. And Mikal will join later with the demo and present himself. And this is Scylla. So the agenda, I'm going to quickly explain what is Alternator, the DynamoDB API for Scylla. Then we're going to switch gear to talk about Kubernetes and Scylla operator. And then we're going to mix the two with the live demo. And the live demo will include an interactive tic-tac-toe game that hopefully you guys can play with each other during the webinar. So why Scylla and Kubernetes? Why DynamoDB and Kubernetes? So Scylla is a great database. Admit it, I'm a little bit biased because I'm working here. But it's a great database with great performance, but managing it do require some expertise. There are all kinds of operations like repair and outscale, downscale, upgrade, backups, everything that you need. And if someone on this session is managing database and production, you know it's not trivial. So Kubernetes try with some success to take this kind of DBA logic, if you will, and automate it. And this is what we did with the Scylla operator. So we try to add as much logic as we can to the Scylla operator. So doing operation like outscale, for example, become, I don't want to say trivial, but become much, much easier. And I'm sure that everyone on this session is aware of Kubernetes. It's, unless you, I don't know, been sleeping for the last 10 years or something. So what is Alternator? This is something that many of this session might don't know. So when we started with Scylla 6 years ago, I think the first API that we implemented is compatible with Apache Cassandra. which is a binary protocol called CQL. Lately in the last 2 years, it's been some time, we also added a DynamoDB API to Scylla. DynamoDB is very different from the Cassandra API. It's based on REST and JSON. I will demonstrate it in a second. So it's very different, but the underlying architecture of Scylla is very much the same. So it's not like there is a proxy just before, I don't know if you can understand my hand movement here, but it's not like there is a proxy before the database. The Scylla itself, the core database, now supports the DynamoDB API. Sorry. And with that come everything that you know and love about Scylla, the great performance, supporting of latest SSDs, low latency, etc. Reliability, high availability. So why you should care? Why you should run a DynamoDB with Scylla? You have the AWS DynamoDB, sorry, which is a pretty reliable database. But if you are working with DynamoDB, you know that the pricing can get very high, especially if you start to increase the number of transactions that you are using. So if you are using 10,000, 100,000, a million transactions per second or requests per second, the price can be high. So that's one incentive to look into Scylla. The second incentive, sorry, is you don't want to be coupled to AWS. So let's assume that you are happy with DynamoDB and AWS, but you actually want to move your deployment to Google or Azure cloud, or you want to run the same logic on-prem and you don't want to rewrite your application because it's already working with DynamoDB. That might be a good incentive as well to look into the Scylla Dynamo API. And I know we have a few customers that actually this was a driving incentive for them. So they wanted to move away from different reasons from the cloud and minimize the investment in changing the application. So Scylla is a good solution for them. And so less of a vendor lock-in, if you will. I already covered that. And so those of you using DynamoDB might ask yourself, what is the support level of Scylla in all of these operations? So this table actually doesn't give you the full picture. This is why I add a link at the bottom. You can go to the documentation and see all the fine details. So we do support like 90% of the protocol, non-scientific number. We support table operation, item operation, batch operation, and such. In some of the operation, we are still missing a few items. For example, table operation does not include altering the schema after you created the table. We are working to fix that. We're also not fully compatible with TTL and streams and multi-partition transactions. And we are working to complete all of them, but at least from customer I talked with so far, for many use cases, what we have is good enough. Because we do cover most of the API. Other item, which I mark here is not, NC is not compatible here. So Scylla do have a backup and restore, do have tracing, do have monitoring, do have alert. And we're going to demonstrate a few of those later, but those operations are still not compatible with DynamoDB. So the functionality is there, but it's not exactly the same API. Let me skip now to a very quick demo. I hope you can see my screen here. So what I'm going to do now, I'm going to quickly launch a local Docker instance running Scylla 4.1. I don't know if you can see it, but I'm opening here the Alternator port 8000. And once I do, this Docker parameter actually run the DynamoDB-compatible API. The next command I'm going to use is not related to Dynamo, it's node tool status. For those of you not familiar with Scylla, node tool status, node tool in general is a tool that we inherited from Apache Cassandra that help you manage the cluster. In particular, node tool status gives you the status of the cluster. And in this case, the entire cluster is one small Docker instance I'm running on my laptop. But since I did get a status, I know that Scylla is up and running. And now I'm going to use create table command. And this simply works. It's just, I don't know if you, let me go up. I don't know if you managed to capture all the details, but this is the AWS command line tool. It's not something that we develop. What I wanted to demonstrate here is that you can use the same tooling that you use with DynamoDB on AWS. You can use the same tooling with Scylla, and it will just work because the protocol is compatible. So it's not like we needed to develop our own clone of AWS CLI tool or drivers or anything like that. It just worked because the API is the same. And let me demonstrate also a put item operation. This operation just insert an item to the table. That the item itself is in item.json. Let me see if I can open it. Okay, this is the item, artist, song title, and album. It's an example that we actually copy directly from DynamoDB documentation. So I'm running here the same example that AWS is using, and it just works because the protocol are compatible. Last, let me try to do a quick query on the table, and I see the result here. So that's basically what you have here. Here I actually only put the create table, but I hope now that you're convinced that the protocol are just work. Another tool that I'm not going to demo here, but I find it pretty useful is, I don't know how to pronounce it, Dynobase, I guess, Dynobase. I have a spelling error here, and this is the actual URL. It's a cool UI tool that helps you work with DynamoDB, but also with Scylla because it's compatible, allow you to create table, see the schema, insert data, remove data, everything that you expect from a database UI, so you can check it out. There are other similar tools. There is AWS Workbench, NoSQL Workbench, work with Scylla as well. So now let me quickly run a pool here that okay, I hope you can see the pool. It's just a quick answer of how many of you guys are actually using both DynamoDB and the Alternator. So we'll let it run for a few seconds, and let me switch to the second topic of this webinar, is Kubernetes and how we run this DynamoDB-compatible database on Kubernetes. And in the meantime, you can answer the poll or not. It's not a must. So what is Kubernetes? Kubernetes is basically a platform that help us manage a Scylla cluster or any other cluster. In this case, it's Scylla. And the way that the Kubernetes work is the user, and this is me here, or one of you, is requesting the Kubernetes or the controller to change a deployment or to create a deployment. And the Scylla is deployed as everything in Kubernetes in pods. As you can see here, each of the pods include both Scylla and a sidecar, actually more than one sidecar. And every request that you send to the cluster, the operator and the controller try to match the manifest, the YAML manifest that you created, and set up the deployment accordingly. And I will show it in more detail in a few seconds. So this is again the pod. We're actually running, as I mentioned, two sidecar here. One is called sidecar. That's a process that launched Scylla. The second one is manager agent. Those of you familiar with Scylla know the manager already. It's a tool that helps us do recurrent repairs and recurrent backup. And we're using the manager agent here as well. So how does the Kubernetes or Scylla operator work? The way that it works, there is a YAML manifest that describes the deployment status as you would like to see it. So in this example, I would like to see Scylla version 3.06, which is pretty old. We are on 4.1 right now. I would like a cluster of 2 nodes, and I'm basically pushing this YAML descriptor to the Kubernetes controller. The Kubernetes controller have 3 phases, and this is not unique to Scylla, by the way. This is a Kubernetes one-on-one. 101, and I'm not a Kubernetes expert, by the way. So the way that Kubernetes works, it's observe the new manifest. It's calculate the difference between this manifest and the actual deployment as you understand it. And then you reconcile the reality with this manifest. So if, for example, and this is something that we're going to demo, I'm changing the number of members from 3 to 2. Then the operator identify there is a gap, calculate what they need to do, and then decommission a node. And vice versa, if you're adding a node or adding a data center or adding a rack and all of that. And the way that the terms in Kubernetes map to Scylla terms is as follows. So each Scylla member or a node in Scylla is mapped into a pod, as we've seen earlier. Each rack is mapped into a stateful set. For those of you not familiar with Scylla, rack is, as you can guess, it's an element that affects the replication strategy. So if you are using rack-aware strategy, as it's called in Scylla, Scylla will try to position each replica of the data on a different rack. And in Kubernetes term, it's a stateful set. It's stateful because Scylla actually had a state. It's not like, those of you who are familiar with Kubernetes and stateless application might don't have experience with stateful set yet, but stateful set are useful if you want to run a database or anything with a lot of state. And of course, database is all about state. A data center is translated to a collection of stateful set, and the entire cluster is represented as a CRD. And Mikal will actually demo the Scylla CRD for Alternator for the Dynamo API and how a change in this CRD affect the deployment. So now let's switch to the demo, and Mikal, I think you can present on your side. Try to.
All right, hello. So we'll run this short demo today. In this demo, we will run on a Google Cloud Kubernetes engine. We would deploy the Scylla operator. Using the Scylla operator, we would deploy the Scylla cluster and the monitoring stack. And on top of that, we would have this tic-tac-toe game that you can all play, and we encourage you to play. So let me now share my screen, maybe. All right, so first of all, for the best experience, I think what you can do, you can go to github.com/ScyllaDB, Scylla code samples, and all the demo I'll be showing today is there, and you can run that all by yourselves. In order to do that, there is a README, and there are a bunch of scripts here. So it's fairly easy to get started, and there's a webinar.sh script that would walk you through all the steps. There are also other scripts that are responsible for particular actions. So the gcp.sh would set up the GKE environment, all the node pools, and all the Kubernetes resources. And then the webinar would guide you through setting it up again. Let me, for your convenience, let me paste the link to it.
We already did, Mikal. So
I already did that. Thank you very much. And there's another link I want to share with you. So that's the link to the demo application. So let me show you that. I have a terminal here, and I have checked out the repository. As you can see, there are all the scripts you want. I would not run all the webinar, SH, or the GKE because those scripts tend to take quite a bit of time. So what I can show you is that we have everything deployed at the moment. We have a cluster with 3 Scylla nodes, and a tic-tac-toe game. One important thing, so if you all are already familiar with the Scylla operator, or you have seen the previous webinar, or you have some more awareness of how Kubernetes works in general. So here, this file is the cluster custom resource definition for the demo. So if you scroll down to the bottom of this file, you would have the specification that we request from Kubernetes or from Kubernetes, Scylla Kubernetes operator. And to have the Alternator enabled deployment, what you need to do is the line 85. So you just need to specify the Alternator port. And when you do that, you just convert the standard Scylla deployment into an Alternator-enabled Scylla deployment. All right. So going back to Kubernetes, like I said, there is a bunch of scripts, and one of them is tic-tac-toe.sh. Just to give you a flavor how this works. So this script tries to deploy the replica set for the tic-tac-toe game, which is located at tic-tac-toe.yaml, and then it tries to get the logs and IP from Kubernetes. And now we can open the game. This game is something that was developed by Amazon and to highlight some of the features of DynamoDB. So this particular game runs on top of the Scylla-enabled Kubernetes deployment, right? So in order to do that, to use it, you first need to log in. I will log in with Mikhail, all right? And once you log in, you can create a game asking a friend to ask. So let's, so we can invite your friends to play a game. Well, I invited Loy, who was the last in the chat. Well, no response.
Mikhail, I invited you as well. You can try.
All right. So thank you very much for your invitation. So we can play this little game. And I highly encourage you to play this game as well with other people who are in the chat. Just send your login and invite each other. Because with that, we would be able to generate some load in the cluster, and I would be able to show you the dashboards and how it looks. Right, so let me quickly switch to the monitoring dashboard. All right, so if we go to the monitoring dashboard, there is a special or dedicated Alternator dashboard for Scylla. We probably want to change the refresh rate to 5 milliseconds, oh, 5 seconds, of course. And as you can see, there are data plane actions which are put and get requests to the Dynamo API. And when we're playing the game, the stats are recorded, and you can see the usage of your cluster. As you can see, right now there are 3 nodes. We're still playing the game. All right. Let me put the metrics here. And what I would like to do now is invoke another command, which is edit cluster, which would run the edit command for Kubernetes. And what you can see here is, like, you can see two things. So here's the spec that we defined. And by the bottom of it, there is a status, which says what is actually deployed or what operator believes is deployed. So we have 3 members in the US West RAG. And that's exactly what we requested. However, we want to change that to only 2 members. We're downscaling the cluster. There is little load. Few people will actually play, or Scylla doesn't even notice this load, of course. So we change that. They are all running, but in the dashboard, you can immediately see that one of them started leaving, and that node should stop serving the load. All right, so I think I'm going back to, again, I highly recommend that you check out this Scylla code samples repository and deploy the cluster by yourselves and play with it. Of course, you can play this game for now, and we would not close the game. Going back to you, Zach.
Okay, thanks, Mikal. So just to recap what Mikal demo. So we have a Scylla cluster running on Kubernetes. The Kubernetes is hosted on Google in this case, on the Google Kubernetes. And the actual application that we are running is an application that was wrote by AWS team as an example for DynamoDB. So we simply took this example, changed the IP in the backend to connect to the Scylla cluster instead of DynamoDB, and just run the example. And I actually didn't complete my game with Mikal, but I can already see that I'm losing there, so it's fine. So the 2 projects that are involved here is Scylla itself. It's an open source project. You can go to a ScyllaDB Scylla and browse the code if you want to. The Alternator, which is the DynamoDB API, is available since Scylla 4.0 as GA. In previous version, it was there as experimental, now it's GA. And you can use it either in Docker, as I demonstrated earlier here, or in, of course, the Kubernetes also run Docker in this case. But you can also run the DynamoDB-compatible API as an AMI or in Scylla Cloud or whatever you install a Scylla on. This feature, the DynamoDB API, will be part of the next Scylla Enterprise that will be available in the next few days even. And there is a link here to the documentation, but you can just go and look in Scylla documentation for Alternator to see everything about it. The second project that we see in here, also open source, is the Scylla operator, which is the operator for Kubernetes. It's included a lot of examples of deployment in Minikube, in Google, Kubernetes Engine, in AWS, and such. And we are not considering the operator a GA yet, or production ready yet. We are considering the beta. But I know for a fact that some brave user, if you will, already using it in production because we get a lot of feature requests from them and issues. And everyone on this call is more than welcome to do the same. Just run the operator, launch the cluster. You can follow Mikal example with the tic-tac-toe or a different example. And we will be happy to get your feedback. So I mentioned that the Scylla operator is still in beta. I want to quickly cover what is supported and what is not supported. So the Scylla operator already supports topology changes, as Mikal demonstrated, downscale, but also outscale. We support configuration change, rolling upgrade. and integration with Prometheus and Grafana, as Mikhail demonstrated. We are still working on a couple of items, so mostly around testing before we can call it GA. Sorry, we're working on manager integration and a lot of benchmark. And I already seen a question about benchmark in the chat, and we'll try to answer it later. So by that, that's the end of the formal part of the presentation, but now we have time for Q&A. So let me drink some water and start answering questions. Okay, just a second. I hope you guys can still see me. So there was a question earlier in the chat about performance, in particular comparing performance between, where was it? Between different Kubernetes hosting. I think about Google and AWS. So I don't think we did any real performance tests on Google yet, but Mikhail do have experience in testing Scylla on Kubernetes on AWS. So Mikhail, maybe you want to talk a little bit about that.
All right, so we're in the process of optimizing performance for the Kubernetes deployment. At the moment, there's some slowdown. So we identified the bottlenecks, and we're working towards providing a solution that runs almost as fast as Amazon. So I did a benchmarking that compared the operator, the Kubernetes deployment using Amazon EKS compared to what we have with Amazon AMIs that we use for ScyllaLab, for instance. And the results are that we get a slowdown of what we can get down to a slowdown of a few percent. But at the moment, it's there is a difference between running on Kubernetes and running on AMIs without Kubernetes.
Okay.
So the answer is that there will be a cap for using Kubernetes at the moment. But we're working on fixing that, and there is opportunity to eliminate that.
Yeah. And once we have result, of course, we will share them probably in a blog post format. And another question that I see here is about the Dynamo API and do we support streams? So I think I had a slide about it earlier, but so the answer is not yet, but it's coming very soon. Scylla have a feature that it's still experimental that we call CDC, which is basically the same as stream in the Cassandra world, but we are bringing this feature to our DynamoDB API as well. And actually I saw even earlier today commits coming in with support for streams. So if you are following Scylla GitHub and the PR that's coming in, you can already see that it will take some time to test it and run it into a production system. Okay, second, I see more questions. So a question from Kevin, and apologize about pronouncing your name. My name is very hard to pronounce as well, so I can feel your pain here. So the question is, does COM, Amazon, AWS Java SDK work for connect to Alternator for JVM project? So to be honest, I don't know. I'm not sure that we tested with the Java SDK. I did work with a couple of other projects like the Python SDK and even the Lambda function. And all of them are able to connect easily to any other IP that you provide. So if you provide the IP of your Scylla cluster, it will simply work. But to be honest, I didn't try it with AWS Java. Mikhail, have you tried? We're not working with Java.
The REST API, so that should work as well.
Okay, so I'm pretty sure it's work, but I haven't tested it myself. Second question, any tool from Gala The question is, any tool to validate and compare the Scylla performance on Kubernetes and regular instances? So to do that, we are using standard industry tool for benchmarking. YCSB is one of them. YCSB is a performance benchmarking tool that uses a lot with different NoSQL. It has an API for DynamoDB, so it can work with Scylla as well. And Mikhail, is that actually what you are using, or am I?
So in the benchmark, I was not working with Dynamo, to be honest. So I used the standard Cassandra stress tool.
Ah, okay. Okay, so you tested the, okay. So you tested actually Scylla on Kubernetes, but not the DynamoDB on Kubernetes. Okay. But we are doing other tests with YCSB. So YCSB is a generic tool to do this kind of test. And this is what we use to test the Dynamo API of Scylla. To test other API, we have other tools. Another question from an anonymous person this time. Do you support Azure Kubernetes service? And have you tested the DynamoDB alternative on Azure? So I don't think we tested on Azure yet, at least I didn't, and Mikhail, you tested on Google and Amazon, right? But not Azure yet.
Yes, so I don't think we managed to get to Azure yet.
Okay. Okay, so as everything with Kubernetes, it should work, but of course, some adjustment might be required. So as people with some experience now, so I cannot say it will work out of the box, but definitely we are planning to try and run it on Azure as well. Okay. I don't see any more questions. So, but if you do, I don't know, in 10 minutes, remember that you did have a question, drop me an email. My email is it's not on the screen right now, but my email is Zach, tzach@ScyllaDB.com. And you can also contact our support, or we have a very active Slack, which people can join and ask questions at any point. You can find everything, all the email and the email list and the Slack on the website, and please join and join the conversation. We will try to follow and answer as quick as possible. Okay, thank you very much and have a good day, good night.